Hi guys, so in this video lecture we are going to talk about the nomenclature of alcohols. So let me write down the heading first. So nomenclature Nomenclature of alcohols. So as you know that we actually represents alcohol in the form of ROH, okay, and the suffix we use for alcohol is ol, okay. So just some rules that you have to select the chain having alcohol and you have to give the preference to alcohol first, then alkene, alkyne and other substituents, okay. So select the chain containing alcohol group and give it preference over alkene, alkyne and other substituents or locants, okay. So the priority rule should be as follows, that we have first will be between alcohol or double bond and triple bond, or alcohol, alkenes and alkynes, and in turn alkene and alkynes will be given priority over substituents, okay. So this is the priority rule which must be kept in mind when you are giving the IUPAC name of compounds, okay. So let's start off with some examples. So we have ETOH, the name would be ethyl alcohol. Second, let's say we have this, then the name for this would be propyl alcohol. So it won't be in commonly you can say it's ethyl alcohol, but when you talk about IUPAC name, it should be ethanol, okay. Eth is the word root and ol is the suffix, okay. And for this you can say propanol or propane 1-ol, okay. Similarly for this you can say that it is prop 2-ol, propane 2-ol, 2-ol, okay. Let's see what happens in this case. So in this case the name for this compound would be 3-methyl butane 2-ol. Why? Because we'll be giving first preference to, we'll be starting the numbering from this carbon atom. Why? Because on this carbon, from if we start numbering from this carbon atom, we can find the OH group attached at second carbon position, okay. This is third carbon, this is the fourth carbon. So this is 3-methyl butane 2-ol, okay. Let's look at other examples. We have this one. So the name of for this compound would be, again numbering would be starting from this carbon atom. So 1, 2, 3 and 4, again 3-methyl this time it will be butanol or butane 1-ol, both are same. Let's discuss for this compound. We have something like this. So again first, second, third, fourth. So this would be something like but 3-in-1-ol, okay. Let's do for this compound. We have something like this. So again first, second, third and fourth. Why? Because alcohol should be given higher preference over alkenes and alkynes. So this would be but 2-in, as on second carbon itself we can find the double bond and 1-ol. Let's look at another example. We have here something like this. So the name for this compound would be but 1-in-1-ol dash between 1 and ol, okay. Let's look at this example. We have something like this. So again, first, second, third, fourth and fifth. So we have 3,4 dimethyl, and then so 1 2 3 4 5 here. Then we can have 3,4 dimethyl, and then pentene 2-ol. Oh sorry, I missed the ene part. So pent 3-ene 2-ol. So this would be the IUPAC name. Let's look at another example where we have something like this, Cl and OH here. So again, if we start numbering from this carbon atom, we should be getting OH at position number 3, and from this atom also we are getting the position, OH at position number 3. But here we can find the double bond at first carbon atom, and we are finding the double bond at 1 2 3 4 carbon atom. As we have OH at the same position, either we start from this carbon atom or this carbon atom. Next in the priority rule, it comes the alkene. So alkene is getting first number here, and it is getting 1 2 3 4th number here. Hence we will be starting numbering from this carbon atom. So 1 2 3 4 and 5. So the answer would be 4 chloro, pent, 1 ene, 3 ol. Okay, let's look at this example. We have here simple a CH2CHOH. So the name of this compound would be simple eth 1 ene 1 ol. Okay, we have another compound, something like this, a triple bond CH and CH, 2 and CH3. Let's name for this. What would be the name of this compound? Again, you have to select the maximum carbon chain, longest carbon chain. 1 2 3 4 5 6 is the longest carbon chain. If we start from here, we can get OH at the 4th position, and if we start from here, we can get the OH at the 3rd position. So we'd be starting numbering from extreme right. Okay, so then the answer would be simple hex, I think 4 ene 1 2 3 4 4 ine probably, and then 3 ol. Okay, so what happens in this case? We have OH here. So the name of this compound would be, again we'll be starting numbering from this carbon atom. By now you should be clear why we are numbering from this carbon atom. So the name would be hepta 4,6 diene 3 ol. Okay, let's start with the 14th example. Here we have something like this, a cyclopropyl ring here as a substituent, CHOCH3 here. So what would be the name of this compound? Again, we'll be starting the numbering from this carbon atom. I think the reason is clear enough. So the name would be hex 4 ine, or better 4 cyclopropyl. 4 cyclopropyl, then what can come? 3 methoxy, this group at position number 3, and it would be alkoxy. So 3 methoxy, and then we would have hex 4 ene 2 ol. Okay, 1 2 3 4, alkene is at 4th position, 1 2. Okay, let's start off with this example. Here we have Br attached here and OH here. So what would be the name of this compound? The name of this compound would be simple 3 bromo butane 1 ol. Okay, let's look at this example. We have this compound. So what would be the name of this compound? Again, cyclo prefix would be used, 1 degree prefix, cyclo. Then we have, this is the cyclopent, and again this is the first position, this is second, this is third, this is fourth, this is fifth. So we have cyclopent, again 2 4 diene 1 ol. Okay, now we have something like this, 2OH on the same compound, on the same carbon, so the name would be simple ethane 1,1-diol. We'll be looking at this compound in our next subsequent set of chapters and lectures. So this is an important compound as far as the future course is concerned. Again, we have something like this. So this is also diol, and the name would be ethane, in this case 1,2-diol. Okay, and again this compound is important for our future lectures. So you may not remember it, but we'll be seeing these two compounds so many times that you will actually get good understanding of where these compounds are used, and you may not remember it at this point of time, but eventually you will have it on your fingertips. Okay, so next we have something like this. We have OH here, double bond, and let's say Br and Cl here. Okay, so the name of this compound would be, again we can find that at first position OH is attached. Okay, and if we start the numbering from this, we can either start the numbering from this side or from this side. Okay, if we start the numbering from this side, then we will find something like, we have 1, 2, 3, 4 and 5 here. And if we start the numbering from this side, we would have something like 1, 2, 3, again 4, 5 and 6. Okay, so where should we actually pick, how should we actually pick the which numbering order should we be taking? Obviously we will be taking this numbering order, which is clockwise. Why? Because this is not a double bond, it is a substituent. Still it is alkenyl substituent. Okay, and chloro and bromo would be given higher preference over alkenyl. Had it been an alkene, then it would be given first preference, but this is not the case here, hence we'll be giving the third position at chloro only. So we will not be starting from this, instead we'll be starting from this. Okay, so the name would be 4 bromo, we have 3 chloro, and then we have 5 ethynyl. If you just look at the why we actually gave the third number to chloro then ethynyl, because this the character starts, the first character of ethynyl starts with E and this starts with C, hence in alphabetical order chloro would be given higher preference over ethynyl, hence we started the numbering from this carbon atom. Had it been a double bond here, then it would have been a different case, but this is not a double bond case here, hence the numbering should be starting from in the clockwise direction. Why? Because C comes before E in the alphabetical order of the name of the prefixes. 5-ethynyl cyclohexane 1-ol. Okay, so now OH and ET. So what would be the name of this compound? No confusion, 1-methyl cyclohexane 1-ol. Okay, let's look at this compound where we have OH and ET on different positions. This is OH and this is ET. So the name of this compound would be 3-ethyl cyclohexane 1-ol. 3-ethyl okay, So with this we come to an end of this lecture. We'll meet in the next lecture. So till then, good luck and goodbye.